Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
All right, greetings everyone, and welcome back to another great episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, well, it's more on our A+, what is it, the 220-901, if I'm not mistaken. And joining us back in the studio again for more on CPUs and cooling solutions, our good friend, Mr. Wes Bryan. Wes, glad to have you, my man.
Hey, man, it's going great. Thanks for having me back. That's right, part 2 on CPUs because, well, I talk a lot in the first part.
There's a lot to talk about.
That's right. There's a lot of different characteristics that we have to talk about. Let's just take a real quick second and recap some of the things we talked about in the first part when it comes to the characteristics of the CPU. Remember, one of the things that we did mention is speed, right? When we talk about clock speed, if you will, that's how many calculations can a CPU perform in a given second. And it is measured in hertz. Remember, if you have a 2.8 gigahertz processor, like Dan mentioned in the first part, that's 2.8 billion calculations in a given second, which is absolutely crazy and mind-boggling. We also talked about multi-core processing. Multi-core processors is because of the fact that processors have gotten smaller and smaller and smaller over time. So they found a way that they could put more than just one processing unit in the center of that little green wafer that you see that is known as our CPU. We also talked about the caching system. Remember, because the CPU is so darn fast, faster than anything on the CPU, if we have a common set of instructions that the CPU is always calculating, we put those in a non-volatile region of memory called cache. I don't know if I mentioned this, but let me go ahead and mention it. It's called SRAM, that's static random access memory. So when the power is lost, those instructions do stay behind for a period of time. Remember, it's a hierarchy, L1, L2, L3. Most common instructions in L1, and then it prioritizes the lower priority instructions in L2, L3. Both L1 and L2 are inside of the CPU, most likely today. You even have portions of the motherboard that might have a dedicated SRAM bank called L3 cache. We also talked about hyperthreading. Remember, hyperthreading is a way to feed more than one sequential stream of information, basically allowing, for instance, two applications to have their data processed at the same time. We also mentioned things like virtualization, the ability for the CPU to have more than one operating system running in any single physical device. So all great things. We also talked about the architecture, 32-bit versus 64-bit. Keep in mind, when we talk about 32-bit, we're talking about a limitation of 4 gigs of RAM. 64-bit, we are talking about, we don't have that limitation. All right, and there are some other things that we talked about, but those are some of the bigger things that you definitely have to know. If that doesn't make sense, then jump back over and see part 1, and we'll see you back here in a little bit. Now what we're going to do is we're going to dive into, well, what do we use to keep those CPUs cool? One of the major concerns when it comes to any kind of system unit is proper thermal management. And what we mean by thermal management is the CPU, we have a lot of voltage being pumped into these CPUs. Dan, I've seen some boards that are the higher end Intel boards where they have a dedicated 600 watts just to the CPU alone, let alone what else you got going on inside of your machine. So they get very hot. So it is important that we have different components. We are aware of the different components inside of the system that help to dissipate some of that heat. Now, things that we do talk about in other episodes, I want to just kind of mention here because although it's not expressly called out on the objectives, you should know it as an IT tech inside of any kind of A+ type situation and on the exam. Remember, one of the first starting points of your cooling system is your case. You have strategically placed vents, if you will, and the ATX motherboards. One of the things that standard did is it kind of reversed the way the circulation would be done. What happens is it brings cool air in combination with fans into the system. As the heat rises, the fans exhaust, if you will, the heat out of the back of the case. Keep in mind, during normal operations, your case on your within your system unit needs to stay closed because it is part of the cooling unit. So I do want to make mention of that. It's not, again, in the formal objectives here. There's one other thing that's not in the objectives here either when it comes to cooling, and that's also your power supply. The other thing that the ATX motherboard, that standard that's been around since 1995 when Intel released it, is it rotated the entire board and put the CPU directly under the power supply fan so that the power supply fan could help to assist the cooling. So A couple of things, like I said, that aren't here in the objectives that we're talking about, but a major part of your overall cooling system. Because, well, Dan, you read off the title here, appropriate cooling. It's not just about what's up with the objectives. So that being said, let's go ahead and talk about, when it comes to the CPU itself, one of our first, if you will, primary component in this overall cooling system. And that's something known as a heat sink. All right, and I got a little bit of a diagram here, and we'll actually look at a heat sink too coming up. Notice this is our, I can almost guarantee you this is probably a diagram of some AMD socket because of that zero insertion force socket that we talked about. The little handle we showed you in the motherboard, when I open it up, kind of pulls the socket back and releases those pins that it's grabbing onto. Well, notice this little piece. It almost looks like a radiator, right? This radiator is what's known as the heat sink. And what the heat sink is really nothing more than a radiator that's a piece of metal, if you will. And what it does is it actually, in theory, it increases the surface area of the CPU drastically. And that's because if you were to take a hammer, right, and you were to mill this down into a flat piece of metal, and I don't know what the percentage is, I've heard it before, but I can't think of it off the top of my head, that it would be a big old flat piece of metal, and that's what it's supposed to do. It's supposed to increase the surface area of the CPU. Now, the other thing that it does is it actually draws heat into these valleys right here, into the valleys between it. And what you'll see is that we have something on top of it known as the CPU fan. And the CPU fan is responsible for taking that air that's essentially heated up within those valleys, and it kind of dissipates it. It dissipates it away, blows it out of the heat sink itself so that it helps to assist the cooling. Now, more specifically, when you have a fan like this with a heat sink, that is what is known as an active cooling system. All right. You also have what are known as passive cooling systems, and these passive cooling systems are found in things like your very, very small form factor motherboards, like the Micro ATX, Mini ITX, Pico ITX boards that they have now, and that's because they use very low-powered CPUs, so they don't generate a lot of heat. Right? Low-powered CPU not generating a lot of heat. We can just put the heat sink on itself, and it's doing its job passively. That's a passive cooling system, or sometimes called fanless, if you will, really for obvious reasons. Now, let's go ahead and let's kind of look at this motherboard. We've got a whole different all different kinds of cooling units here, and I was kind of joking around with Dan. I said, look at the size of this heatsink here.
You'll notice it's the size of your hand.
That's right, that's right. Dan suggested that I wear this as a hat as big as the sucker is. Probably contact the mothership while I'm at it.
Yes.
But notice the flat surface here, all right? Well, I want you to understand, too, that there are a couple of extra things that we have with the heatsink that go along with it. It's not just the heat sink and just the fan. But you can see that these are actually like, it's kind of like a heat exchange system, right? Where it pulls the heat away from the CPU. As the CPU heats up, it brings this hot air or the heat into itself, and it dissipates it up into the vents here. And then if we have a fan on place, I believe this fan, if I remember right, was side mounted here, and it would blow it out the side. But keep in mind, you also have top mounted fans like you see here too. Now, if you're a little OCD, you might notice something about this fan is it's kind of twisted. I know one of our other hosts here didn't like that. He's like, man, I need to be asymmetrical, symmetry. That's right, yeah. Symmetrical. And don't worry about that, because this one here, if I was to lift this up just a little bit, you'll see that this is actually more of like a cylinder, right? But the principle is the same. And then what you have is you have a fan that spins and it blows the hot air away. Keep in mind that it's typically connected to the motherboard, and that's something that you want because part of the chipset, and really the BIOS or the UEFI system, it can actually detect what the heat, the core temperature, core voltage, core temperature of the CPU, and as that heat rises, it can apply more voltage to this fan and it can increase the RPMs within the fan. Now, that's not the only thing we have too. Remember I told you that the system unit also has system fans as well. And we've got a few different types back here, and you can see that they are all different shapes and sizes. And I want to talk real briefly about the different shapes and or sizes that we have, because there's some different characteristics. And honestly, ladies and gents, I don't know how specific they're going to be. to the characteristics of a fan, but you should know this. We've kind of said throughout this series that it's not just about what's on the certification objectives as well, but it's about making you trained if you're going to be an IT tech. It kind of give you the information. This is what's known, if I remember right, this is a 120 millimeter fan, I believe. They do have slightly bigger, those not quite as common unless you're talking about a gaming rig, and that's 240 millimeter fans. This is a common size fan here, in the fact 120 millimeters. You'll find a lot of cases that have brackets here that already line up to this type of fan. This is typically the fan that's going to be set on the front and on the rear of the case. And again, you'll have to pay attention. I don't know if this one has it on it. Usually what you can see on the top somewhere, and yeah, I don't see it on this one, you'll have directions that shows you which way this spins. And you got to keep in mind that on the front of the case, due to the ATX standard, it's an intake fan, so it draws cool air, and as the heat rises, the rear fan is typically an exhaust fan, so it's a pull-push system, if I believe I said that right. And this has also got the little 4-pin, it's called a Molex KK connector, and again, I don't know how specific they'll get, but just keep in mind that when you have the 4th pin, what you do is you have your positive, you have your negative, you have your ground, and then you also have a 4th pin that the BIOS can actually control, or the UEFI system can control, doing things like detecting the RPMs of the fan. If it's a variable speed fan, it can apply more voltage and raise the RPMs. Now, remember that RPMs, guys, we're talking about no different than when we're talking about hard drives or anything else. We're talking revolutions per minute. And that might be a contributing factor. Not only the size of the fan, common sizes, like here's another common system fan. That's an 80 millimeter fan. You usually see this on the sidewalls of the cowers too. Could see 2 or 3 of them across the top as well as even 120. I've seen some gaming rigs that are really expensive, very good fans that have 3 of these right along the top of the case as well. And it's all relative too to where the power supply is positioned as well. Now, they don't always have to follow a specific standard because you'll see that, see this one doesn't, you can see it's a slightly smaller. So to tell you the truth, off the top of my head, I want to say this is the one that's 80 millimeter here. And you can see that this is a rotary DC brushless fan too. That's not so important, if you will, for the exam, but you have also bearings in there too. So the real takeaway from this I want you to know about these fans are a couple of things, right? RPMs, the millimeters, again, 240, 120, and you have the 80 millimeter fans likewise. RPMs, like I said, and then there's another thing, a couple of other things, believe it or not, that are a factor when it comes to the purchasing a fan. And those are CFMs. That's one of the first ones, and that's the cubic feet per minute. How much air does the fan push, all right? Because, Dan, I know I've built some rigs before where we have 2 2100 RPM fans, and one CFMs is a lot greater than the other one. So it means they're spinning at the same rate. They're both using the same amount of power, but one of them can push more air per minute. So that might be a contributing factor. The other thing that I would also keep in mind too is decibels. All right, and you might say, well, wait a second, decibels, what do you mean? Well, I know you've, yeah, I was going to say, Dan, you've been in a server closet. Tell us a little bit about the deafening noise.
Anytime you even open the door, you're like, oh, server closet. When we used to were looking for like network hardware or a closet hardware, and you don't know what closet it is in, you walk around, it's in this one. Because you hear those fans going crazy because they have such a job to do. These things create so much heat that we have to get that heat out of them, and we do that a lot by using fan technology and then just AC in the mess out of whatever room it's in.
Most definitely, and if you're building a rig or servicing a rig where you're replacing it, well, imagine if you're in a data center like I said, like Dan. I know Dan's worked in a large enterprise level business as well that's had these. That's not bad, right? You have an isolated room, typically might even have an entire data center for your servers. Imagine if that thing's sitting next to grandma's workbench. Not workbench, she better, if she has a workbench, that's even great, she's awesome. But sitting next to her desk, right?
She's not
you don't want it to sound like a Huey taking off every time you turn the fan on or turn the machine on. I made the mistake that I was like, when I built my first computer after becoming A+ certified, I'm like, yeah, I need like 4,000 RPM RPM fans, and I need them to spin as fast as they can. And yeah, when you turn the computer on, you can't go to sleep at night.
Yeah, it's a Harrier jump jet. It's crazy.
That's right. So pay attention to decibels too, because again, if you're working with a system that you're building that does voice recognition, the fans themselves can interfere with the voice recognition system. So do keep that in mind. All right, so that's a few things that I want you to keep in mind when it comes to the fans. Millimeters, again, 240, 120, 80 millimeters are common. When you talk about small form factor devices, I've seen some fans that are crazy, the 30 millimeter, they look the size of the quarter, but now we're talking about things like Internet of Things, IoT-based type devices, and I don't really think they're going to call that out on the exam. CFMs, cubic feet per minute. Keep in mind, we had a great comment inside of our chat room that said you need the right appropriate push-pull, right? You need a good ratio because if you pull a lot of cool air in, well, what's happening to that cool air? It's heating up, right? But if your exhaust fan can't push the hot air out the back of the case, well, guess what? You're going to run into thermal management issues that could cause just irreversible damage, because when it comes to thermal damage within a CPU, you can't see it. Very rarely, unless your CPU goes up in flames and you smell it, then obviously you could see it. So it could start to cause erratic behavior. And another thing you have to keep in mind is that manufacturers don't like to refund money for products that you didn't take the time and the concern to be very delicate with them and understand what was going on. And again, sound too. Sound is another thing. All right, now I did mention that we have fans, right? And we have our heat sink. Well, here's another thing in combination with the heatsink. If we could go back to our big old massive crazy heatsink that we've got right here, notice that we have this surface, and I'm not using this. This should be cleaned off, guys. You certainly don't want this looking like it does right here with my fingerprints on it. But what we can't see, and we won't be able to see much if I keep blinding you guys there, is the fact that the bottom of that heat sink it isn't as flat as we think it is, all right? It's actually it looks like the surface of a golf ball, or milling marks on it, scratches on it. And that's the same thing with the top of a CPU. And if we were to put that heat sink by itself down on the top of that CPU, then what we would have is actually an insulator. The problem is you need something that bridges the gap, right, the air gap in between metal on metal, and also helps to kind of smooth out those imperfections. And that's something that has quite a few different names. Commonly, we just call it thermal paste or thermal compound. I know I've heard people call it thermal goo, thermal putty, right, all different kinds of things. But when you're putting, and let me show you here, guys. So I got another heat sink here on the diagram, and you'll see that, again, we've got this surface right here, and this technician right here is putting that thermal compound, in this case putting it a little rice-sized, that'll do you by the way, on top of the CPU, but you also put it over here on the heat sink, and this is a laptop one, but so that thermal paste, if you will, that thermal compound sits in between the heat sink and the CPU, and it bridges that gap, the imperfections, the milling marks, and what it does is it helps to dissipate, to pull that hot air from that CPU, and helps the transfer of essentially the heat into the heat sink as well. So do also know that. Now there's a couple of different kinds, well there's all different kinds of manufacturers, but primarily there's two different kinds of thermal compound. Both of them work just fine. Some people swear by some people don't care. There is your basic silicone-based thermal compound, and great, does what it needs to do. In fact, when I've done warranty work and I've had to replace motherboards and CPUs, that's what they give you, just a little basic tube of that like you've seen in the picture that we had. There's also some that have a lot of metal in them, right? For instance, Arctic Silver is one of the best type manufacturers, and we're not getting any money for saying Arctic Silver is one of the best. It just literally is. It's got a name for itself.
Facts are facts, right, Wes?
That's right. You can't argue with the facts. That if you think about it, what's a good conductor of heat? Metal, right? That's why we're using heat sinks. Well, Arctic Silver has a metal compound in it, right? So it helps to accelerate the dissipation of that heat from the CPU to its heat sink. So you can also see that. Now, there are a couple of considerations, right? If you're using a silicone-based type thermal compound, be careful getting it down onto the motherboard or anywhere other than on the top of the CPU and the bottom of the heat sink, because it is a nightmare to try to clean up. If you have a metal type based thermal compound, be careful. Why? Because not only is metal a very good conductor of heat, what else is it a good conductor of?
Electricity.
Electricity, and that is right. You could electrically arc, right, short circuit pieces. And again, these manufacturers of these CPUs, they work in microns. They can tell what's going on with their CPUs. You're not going to fool them when they say, oh, I don't know what happened. That was a problem with your manufacturing. They can see those wafers in there, and you might run into problems with a warranty if you don't do this right or appropriately and end up short-circuiting your board out there. All right, Dan, so we've talked a lot about the theory in the first part. We have just a little bit more that isn't quite so fun, and just like any A+, we wouldn't be doing you any justice if we didn't have a bunch of specifications that we need you to know. Now, Dan and I know, Dan, when you're going to get a CPU, how do you pick a CPU? Let's say if I bring you in a case and you need to replace it.
I look at the motherboard, I go to Google, I type in motherboard name plus CPU, and a bunch of results come in.
And that's exactly how you should do it, okay? So keep that in mind. I mean, that's absolutely how you do it. You got a motherboard. What does it say the CPU is? What is the socket? I go out and I find the CPU, and I find the socket that matches it, right, for that motherboard, okay? That's how you do it when you are, you're working in the field. However, remember, just like any other profession, you're learning a new language, and CompTIA wants you to know a few specifics when it comes to the different socket types that are out there. So I'd like to take just a few minutes, and yes, I know, guys, it is not fun. It isn't fun. Excuse me, try a little better English there. It isn't fun, but you do have to know some of these things for the exam.
So whip out the flashcards and get ready to write.
That's right. That's right. We're going down memory lane, and I do mean lots of memorization here. So I've got a handful of these different processors. Got a little diagram here, and you'll see that they're Intel-based and they're AMD-based. We'll go ahead and we're going to start with the Intel side, and we're going to work our way through this list here, and I just want to talk briefly about each one. I don't know how specific, guys, on the exam, I can't tell you that they're going to get. But the 775, all right, that's also known as a socket T. Sometimes they have a couple of names, and these CPUs were primarily for things like your Pentium 4 processors. They were for Celeron and your Core 2 Duos, as well as Xeon. The next one is the 1155, also known as socket H2. When we talk about that, we're talking about Intel architecture as well. All these are Intel, and that's the Sandy Bridge, Ivy Bridge, and Xeon. Let me take a second and let you guys know, because we really only mentioned Xeon briefly. Xeon is your enterprise-level server-grade 64-bit processors. Again, you find them enterprise class, and the Xeons are what are known as multi-processor support. You can have up to, I don't even know how many, you can have like 16 CPUs on a single board, right? So they support multi-processor, and they're also multi-core. So boy, doesn't that get twisty, right? Mm-hmm. Multi-processor, multi-core. That's the 1155. The 1156, this is the socket H, and again, these CPUs are the I series, i3, i5, and i7. They also support the Pentium, Celeron, and Xeon. All right. Couple more, guys, and like I said, I know these aren't fun. Just bear with me on this one, guys. We got also the 1366, also known as socket B. These were also for the specifically the i7 series, if you will, as well as Xeon. So the 1366 is kind of like one of the first big boy processors that it says, hey, we're gonna support the top of the line Intel-based processors. Again, i7 and Xeon. Then we have the 1150, commonly also called socket H3. That fits what's known as Intel's Haswell, as well as Intel's Broadwell-based architecture, or family, if you will. Last one in the list on the Intel side, guys, and we'll move over to AMD, is the 2011. By the way, on a side note, 2011 was one of the ones that the boards were quad-channel architecture, so we're talking a pretty beefy setup here. These CPUs, again, higher end. It was a replacement to the earlier 1150 for the i7, as well as the Xeon-based processors. All right, so that's our Intel side. We also have our AMD side, again, advanced micro devices. And kind of tell you what kind of outdated processor I have, or socket. I have the very first one on the list, and that's the AM3 processor. Now, AM3 processors, these were the Phenom series, specifically Phenom 2, Athlon 2, Sempron, and their server-grade Opteron. I'll get that right. It sounds like a transformer,
yeah, I was about to
right?
say, they try to name their processors after transformers. It's crazy.
Yeah, that's exactly what it is. just remember Transformers, right? AM3 Plus was the replacement to that, and that's where we get the bulldozer architecture, or typically what's known as the FX series for a brief time, and also supported the Phenom 2, Athlon 2, and Sempron. Now, the last three here, these last three are what are considered APUs, and we haven't really talked about that, and that's accelerated processing units, and they're lower powered, and they also support things like graphics as well. The FM1, this was called the Llano, right? This is the Llano processor, as well as the Gen 2 accelerated processing unit. I make sure I get that acronym right, and that was the AMD Trinity technology. Last one is the AM2 Plus. And again, remember these FMs, they're low powered, right? Again, low powered boards, they save you money, and they're also, they generate less heat. That's the FM2 Plus. And again, that APU is for the Cavari, and this last one almost sounds like chocolate, and that's Godavari. Not Girdelli, but Godavari.
Yeah.
So again, guys, I know the last bit here, man, we threw a bunch of specifications in. Guys, like I've said many times throughout this series, it's like sit-ups, and you guys can look at me. No, I hate sit-ups, but I want you to take Dan's advice. Get out the flashcards, type the notes. I remember when I was studying for A+, I literally would write these down, and I'd crumble up the paper and throw it away, and then write them down, crumble up the paper and throw them away. And then once I'd passed the exam, I'd do exactly what Dan said. I'd Google it, right? Match it to the motherboard. So a lot of specifications, guys, but don't let it confuse you. Don't let it intimidate you. Just dig in, memorize it, and you can pass the A+ certification as well.
That's right. What Wes says talking about is that repetition. It breeds retention. Don't forget that. So go over and over and over and over and over it until it's like second nature to you. You just go sit in that testing booth and you'll smoke this thing out. All right, everyone. Looks like we've come to the end of today's episode. We do thank you for watching. Signing off for IT Pro TV, I've been your host, Daniel Lowry.
And I'm Wes Bryan.
And we'll see you next time.
Thank you for watching IT Pro TV.